You finish a demanding 9 to 5 shift, sit down at your desk, and that massive technical manual lands right in front of you. You're trying to upskill or clear a tough certification, and the sheer volume of pages feels insurmountable. The default instinct is to open page 1 and start reading linearly. You try to mug up every single paragraph, treating a dense structural formula with the exact same weight as a minor historical footnote. But reading a technical syllabus front to back leads directly to burnout. You spend hours of precious energy on forgettable concepts, and your focus lags when you finally reach the high-weightage topics that actually determine your success. To master complex subjects as a beginner, you have to stop reading like a student. You need to start deconstructing the material like an engineer. That requires a chronological blueprint. Before you even read a single page, you have to bifurcate the raw text into manageable, actionable blocks. On day 1 of your prep, your very first task is to divide a chapter's raw information into 4 distinct buckets. This initial breakdown defines the first bucket, theoretical concepts, where you filter core ideas from easily forgettable trivia. Next, you scan for numerical concepts, separating simple plug-and-play formulas from tough ones that require active practice. The third bucket captures figure-based concepts, isolating visual data like physical apparatus setups or specific diagrams. Finally, you isolate data-based concepts, the hard numbers, tables, and specific codal provisions you have to know cold. This initial triage turns a wall of text into a navigated database. Instead of wandering through the material, you're targeting specific sections designed to build your foundational knowledge. But real engineering problems rarely exist in isolated buckets. Out in the field and on advanced exams, these variables bleed into each other. That leads us to dealing with mix types. Once basics are categorized, you start plotting topics together, blending raw numerical data into the core theory. You cannot grasp a complex figure or data table without understanding the theory mixed into it. By actively studying these overlaps, you begin to predict the complex questions examiners use to test multiple integrated skills at the same time. The final stage of study takes that categorized theory out of the textbook and tracks its life cycle on a physical site. Based on this topic list, the life cycle of any concept starts by defining its base assumptions, followed immediately by its primary functions or applications. This forces you to confront the conflict between textbook theory and reality, weighing common-sense logic against actual field conditions. A structural beam might behave perfectly in a frictionless theoretical math problem, but unpredictable temperatures, material flaws, and dynamic loads change all the parameters on site. To anchor unpredictability, you rely on standard data conditions and match your logic against IS codal recommendations. Finally, you master the application by detailing the sequence of works, identifying test limitations, and planning remedial measures for when things fail. Mapping this complete real-world life cycle is the defining difference between merely passing an exam and achieving practical, reliable mastery on the job. That heavy, chaotic manual is no longer a threat. It has been decoded into a highly organized, searchable mental matrix. This sequential process, bifurcating concepts, clubbing mixes, and mapping applications, strips away the ambiguity of technical study. You stop guessing which details matter and start focusing your energy where it yields the highest return. Before you start tonight's prep session, spend exactly 15 minutes skimming your next chapter using this framework. Identify the core theories, map out essential IS codal provisions, and define the field applications before diving into the heavy reading. When the syllabus is deconstructed logically, the path to mastery is clearly defined. The complexity of the subject hasn't gone away, but your method for dismantling it has finally caught up.